I will stop to share my screen to let the place and the moment to Devon to explain and present his talk. Thanks a lot.
Great, thank you, David. And thanks so much for the invitation to be here. I'm not a human-powered flight expert by any stretch of the imagination, but I have been told by human-powered flight experts that what I'm doing is pretty cool because it's a human-powered vehicle that can fit in the trunk of your car. I've heard that most human-powered vehicles are absolutely enormous. So I'm just going to start today with just a short video that I'll share, and then it'll just be about a minute long, and then I'll go through a presentation that's probably about 20 minutes long. And if you'd like to ask questions in the chat, I'll keep an eye on it and I'll try to answer them on the fly, and we'll have plenty of time for Q&A when we're done. This is hydrofoiling. It's like an underwater wing that lets us fly above the water, but we have to pump it with our legs because there's no motor. And the pumping it takes a lot of energy. And right now I can only pump it for about 3 minutes. But we want to find a foil that'll let us fly forever. I want to figure out if we can fly forever. I've made some friends on this journey. The first is Eirik Bachman. Eirik is the CEO of Wavefoil, a company that produces foils for large vessels. The second is Todd Reichert. Todd is an aerodynamics expert and celebrity in the human-powered flight community. Todd holds a human-powered land speed record at nearly 90 miles per hour, and now he's interested in helping us figure out how to fly forever on foils. We figured I might be exerting close to 340 watts to pump a foil for 2.5 minutes. If we can reduce the power by just 25%, we might be able to pump for 30 minutes. That's 6 miles on a foil. So check us out on YouTube and follow our journey in search of endless flight. Okay, so thank you so much for the chance to talk to you about my passion here, which is seeking endless flight. My name is Devon Manz, and I'm from Canada originally, and I went to graduate school at MIT in mechanical engineering. But I always loved sort of the motion of the human body and was a competitive figure skater in my youth. I eventually found myself moving to New York State, and my wife and I had met figure skating. So we said, let's live on a lake so that we can figure skate in the winter months. And so we did that. And that's when I discovered my next passion. Summer came around and I said, I got to find a summer water sport to do. And about that time, I saw someone on a hydrofoil flying above the water and said I had to get one. I'm 41, so I was a kid in the 80s, and I was a big fan of Back to the Future. And as a kid, you always wanted a hoverboard, and I felt like a hydrofoil is as close as I'll ever get to one. I'm an engineer. I didn't know anything about YouTube, so I figured, why not start a YouTube channel? It seemed to make sense. And we started learning and sharing and really built a community around this sport, which is really very much a new sport. This was my very first hydrofoil 3 years ago, and we needed about 20 kilometers an hour to get this to fly. And this is a prototype I received that's 1.4 meters in wingspan that I received a few months ago. So they've come a long way in a very short period of time. And I think we're realizing that we just got to go bigger to achieve what we're trying to do. Okay, so what is a hydrofoil? I think some of you may know it, but for those that don't, it's really just a board that's attached to these 5 components. A base plate that attaches to the board, a mast or strut that extends downward to the gliding section, which is very much like an aircraft. I'm not an aircraft expert, but many of the people who've been helping me and collaborating with me are. And so I've learned a little bit, probably only enough to be dangerous about flight. But the front wing really generates the lift. The fuselage and rear wing provide the stability and the pitch direction. And I think for many of you, you'll understand exactly how this works. But what's been very novel and something that has excited me immensely was about 3 years ago, I saw someone, what we call pump a hydrofoil. And it's really flapping the front and rear wing in a certain way that we've evolved over time to propel it, to self-propel it. And this is probably one of my fondest memories from last summer. Around midnight, it was pitch black outside. A friend of mine said, who's an amazing photographer, said, why don't we strap some lights to your legs and your head and you can figure out how to pump in the dark, which was very hard because as I come to realize in this experiment, being able to see the water so that you're not too high or too low in terms of elevation above it is how you keep that elevation right. So not being able to see it was very hard, but what it resulted in was really, I think, a great image that I think shows people what we do when we're pumping a foil. It's really a sine wave of the right amplitude and frequency to be able to efficiently propel the foil. So what is it we like to do? So I live on a lake. I'm not an experienced ocean surfer. We don't have any wind, so I don't have any wind sports experience. But as it turns out, that we have an excellent test facility with calm water and wind nearly all the time. So one of the things we like to do is we like to jump off our docks. We call this dock starting. This is a device we invented last summer to hold the foil so you can jump onto it more easily. And then we like to pump around, which I just explained. And then we like to surf different wakes, so passing boats. And then when you combine these three things together, we can create an endless wave on the lake. So I've been able to stay up in the air for about 30 minutes. I'm not propelling myself all the time. I'm resting on different wakes that are passing by, but I'm pumping between the wakes to create our own endless wave. Dock starting is a really neat thing. I only discovered this in the last year or so, but it's become sort of the most therapeutic time of my day, or really my life. I'm someone who hasn't been able to meditate very well or even relax well. I'm always moving. But for me, when I'm pumping around the calm water on the bottom right like that at sunset, it's very easy to stay focused on what you're doing. And this is definitely an experience like no other, and probably as close to what Marty McFly experienced in Back to the Future as I'll ever get. So this is the biggest wave the biggest wake or wave I've ever foiled on. It's absolutely tiny for anyone that's been to an ocean, but this is just the wake of a boat on our lake. And how is this possible? Well, foils have super low drag. There's no board on the water. And as I showed earlier, very few parts under the water. And a small wave is enough to fly. In fact, probably even a 15 centimeter disturbance in the water has enough energy in it to propel you forward. And that lets us ride almost anything on the lake. But we wanted to know how small of a wake we could ride. And very obviously, a surf boat with water ballast to create a large enough wake provides an enormous amount of wake energy. So that's more than enough to surf. We can probably surf about 20 or 30 wakes back behind this boat, and there's still enough energy. And we've even found a jet ski wake is enough. So on the left is just some of the shots we took for a video here on the left. And you can see two jet ski wakes, but we wanted to know how far back on a jet ski wake we could go. And so on the right, you'll see we were able to surf with the proper foil, and you can understand how much that matters. But with the best foil we found among those we've reviewed, we've been able to surf the 6th wake of a jet ski, which, as you can see in the image on the right, is a very small disturbance in the water. So I think one of the cool things about this sport is it really unlocks the possibility of surfing on lakes with very minimal equipment. So we started Wake Thief about 2 years ago, and really we just wanted to start creating a passionate community around this sport. We shared what we're learning, and we're helping others learn on this journey. And we want to find the best foils for the things we like to do, and obviously help excite folks much smarter than us to want to build a foil that will unlock endless flight. But I think many of the learnings that we've had on this journey have helped advance the industry and are helping push the envelope of the sport, but also pushing the envelope of flying on a hydrofoil for as long as we can. So our journey, we spend most of our time reviewing foils and learning the industry. It's quite a complicated industry. There's about 60 brands now, and so we get asked often, well, which ones are the best? This is not a simple sport in terms of configuration. There's 5 main parts. Each manufacturer has multiple components, well, not all of them, but many of them have multiple rear wings, fuselages, front wings, mast thicknesses, mast taper, et cetera, et cetera. And you take all the combinations, and even within some brands, you can create 10,000 unique foils, making the overall industry hundreds of thousands or more foils. So and since the industry is in its infancy, there's still a lot of learning. Is a long fuselage better than a short fuselage? Is a big rear wing better than a small rear wing? So without the sort of capability to look at these without testing, we turned our lakefront into a test facility. So I have a buoy out front of my house. I can see right now it's buried under the ice. And we created a 30-meter test course that lets us test a lot of things like speed and glide. And with camera work, like you can see on the right, we can silhouette 2 images and see which foil glided further. And we came up with a test regimen and a consumer reports like scoring system to kind of methodically go through these foils. And the more we do, the smarter we get. We can kind of, quickly filter out ones that we don't think will work early on. But it's become kind of a really wonderful thing for us because we can help people make a good investment because it's a complicated sport, and I spent way too much money before I figured out what it is I like. And my wife reminds me frequently that my basement full of foils is something that I need to get better at improving. So what are we hearing on the YouTube channel, which actually has done quite well in the last year, a lot better than we expected. I think this sport really captures the imagination of a lot of people. So we hear a lot of things. Where do I buy this? I want one. Which one should I buy? Which are all very obvious questions. But this comment here on the top right is one of my favorites. This guy was so excited about a foil. He said, this video makes me suicidal. He wants one and he can't even swim. So, obviously this is not an easy sport to learn, but swimming is definitely a necessity. So we see a lot of newcomers to this sport asking us about how do they become foilers? How do they get into it? And some of the hurdles that we've encountered and have kind of pivoted the channel towards trying to answer is it's hard. It takes time to learn the sport. Like many sports, the Olympics are on right now, and I watch some of these sports with amazement. Every sport is really hard. Some take longer than others to learn. This is not an easy sport, but it's one that is far less complicated than some of the sports I see in the Olympics. But it does take time to learn, and it's definitely worth the effort once you do. It's complicated. We talked about many foils, lots of decisions. And so we're working hard to simplify this for people. And it's expensive. A foil is $2,000 for an entry-level model, maybe 3 or 4 for a higher end model. Higher end usually means carbon, a little bit lighter. But it's a feeling you'll never forget. And it's a sport that, on lakes you can do with a jet ski, which costs a lot less than a $100,000 surf boat. So the real question is, can we fly forever? So when I first saw someone pump a hydrofoil, I immediately went out and bought one. As it turned out, I would have to buy 3 more before I found one that was as good as I had hoped it would be. And last summer, I was able to pump one for 2.5 minutes, which is about 700 meters of distance. And it was about that time that I met a good friend of mine now, Todd Reichert, who I spent a fair bit of time with, who knows a lot more about this stuff than I do. He's quite experienced in the human-powered flight community, and he shared this chart on the right with me. And he said, I saw your video. I saw you were able to do 2.5 minutes on a foil. He goes, you're probably a healthy man. Let me show you this curve. He goes, all we got to do is figure out how to take power down by 25%. And if we do that, you should be able to fly for 30 minutes. And at first I said, gosh, that doesn't make any sense to me. How can that be? But now I've seen it to be true as I've had the chance to try prototypes that put me somewhere along that line between the two, but not quite all the way to the 30 minutes. But pumping is really about that action I shared earlier, allowing you to transfer from wake to wake and create your own endless wave. If there's boats on your lake, and if there's no boat on your lake, you can just go a really long distance. We found that with pumping, the equipment matters a lot. We're finding stiffness is very important. Probably very obvious to all of you, became obvious to me, is having a high aspect ratio foil with a foil cross section that lets you pump it rather slowly so that you don't have to go that fast and exert a lot of energy overcoming speed or the drag associated with speed. And then technique, I learned about this term called propulsive efficiency. And what Todd taught me was that, the human body's really good at figuring this out. And I probably have a couple hundred hours of pumping a foil. And I find that when I get on a new one, it takes me about 3 or 4 minutes to kind of master the feeling of it. Everyone's a little bit different based on how long the fuselage is, the difference in angle between rear wing and front wing. There's a number of factors that change it. So technique matters a lot. And then fitness, and I think all matter, but I actually believe that fitness is probably the least important. I think with good equipment and technique, we're going to be able to get a lot of people to pump a long way on a hydrofoil. So, we've kind of set the goal. We say endless flight. I think I'll get bored at about 30 minutes, maybe not, but I think 30 minutes is a good target to shoot for. Oh, I'm sorry, I see a chat question. Maybe I should. Okay, cool, great. So thanks, Ian. As a former pilot, glider, I went in a glider once, scared the crap out of me, to be honest. We crash land one of these things. I've probably crash landed probably 10,000 times on a foil, and the worst I have is a cut on my hand from one of the very first times I did it. Much safer than being in a glider. So, all right. So the physics of pumping. So one of the things that we went into is, let's start to break down in a spreadsheet-based model kind of where all the drag's coming from to see what we can find. And I think one of the coolest discoveries from this, I talked a little bit about this, the human body is amazing at figuring out the right technique. And if I break it down into mathematical terms, it's clear that there's a right speed, amplitude, and frequency for every foil. And there might even be 2 or 3 that are pretty close to one another. But your body has a way of finding it, particularly at these power levels where you tend to tire pretty quickly. And I think that one of the most interesting physics discoveries was this idea of a sweet spot, which we shared it in some of our earlier videos and a lot of people pushed back. But I think the longer I do this, the more I realize it, is if you pump too fast, the power becomes dominated by the speed, right? The sort of nonlinearity of speed. And if you go too slow, you start to, stall out and it becomes dominated by other factors. So there's kind of this sweet spot and you got to find it, but we're also realizing that if you can fly a little bit slower, I think our chance of getting to 30 minutes will be a lot higher. But I think the main takeaway and what fuels me every day is that we now believe this 30 minutes of flight is possible. So with the endless wave being possible, we're now kind of a year into this and realizing that the details matter a lot. We've done a lot of analysis to show this, and our hope here is that we can go from today, which is really just circles in front of my house. If I can only go, I can go 600 or 700 meters, but I'm really exhausted, right? So I probably do 400 to 500 meters, and really that limits me to just circles in front of my house. But tomorrow with 30 minutes at the speeds we're going, that's about 10 kilometers. That'll be enough for us to go to, dock start near the Eiffel Tower, go all the way to Notre Dame, do a U-turn, and then continue back to the Eiffel Tower. To give those of you in France, or particularly Paris, an idea of the distances we'd go. And I can't imagine how cool that would be. And I think it just opens up the possibility of seeing a lot of places and sites in ways you hadn't seen before. So, this journey's been a tremendous amount of fun. I haven't ever had more fun in my life. I think to this audience, the message we'd like to leave is we're finding a lot of different discrepancies between theory and experiments. And it's always fun to learn something. I think this is one of the first times I've been the test pilot doing something. I've always learned things academically and applied them. So it's kind of fun to put those two things together. But a lot of times I'm the one going back to the person at the spreadsheet saying, I think you're wrong. So I think there's a lot still to learn here. One of the most interesting ones was the concept of surface drag. I've been told it should be getting harder as we get the foil closer to the surface, but it actually becomes a lot easier. And we're not exactly sure why. I think another one is the front wing, rear wing interaction while pumping. We sometimes wonder if the transverse wave that's created off the front wing is actually flowing water up into the rear wing, giving us some lift on a rear wing that shouldn't be lifting. So there's a lot of things that are still to be discovered that I think will be beneficial to this industry and sport in the future. And if you'd like to stay in touch or reach out to me, here's my email address and you can follow us on social media. So that's all I have, but happy to open it up to questions and comments and thoughts from anyone here.